Hi, in this video we're going to talk about the second case of how do we factor second degree trinomials in the sum product method. There is another video which is about case 1 when the leading coefficient a is equal to 1. How do we do that? There's another video on that. Please watch that. So this must be watched after you watch the first video. This is case 2 when you have a trinomial, a second degree trinomial, and the leading coefficient a, which in this case is 2, when it's a number other than 1. It can be any number other than 1. It can even be negative 1, 1, 2, 3, negative numbers, any other number other than 1. It falls under the second case. So the first two steps are very similar to what we did in case 1. It's to identify a, b, and c first, and then we can find two numbers whose sum is b and product is ac. So that's very similar to the first case. So let's just write down what's a, b, and c in this case. For a you have, when you compare, for a you have 2, for b you have 13, and c is the same as 15. So let's find two numbers whose sum will come up to b, the coefficient b, which is 13 in this case, and the product will come to a times c. In the place of a we have 2, in the place of c we have 15, so when you multiply you have to get 30. So both conditions have to be satisfied at the same time. They have to add up to 30, they have to multiply to 30 and add up to 13. So we discussed previously in the first video that we always start from the product part. So we look at how many different ways we can factor 30. So we know we have 1 times 30 is 30, 2 times 15 is 30, and 3 times 10 is also 30. Out of these three pairs, which one satisfies the condition of when you add them, you have to get 13? When we look at the first pair, we know when you add or subtract, you can only get 30 plus 1, 31, or 30 minus 1, 29, which does not come anywhere near 13. So let's cross that off. 2 and 15, when you add them, you get 17. When you subtract, you do get 13. But to get 13, 2 has to be negative and 15 has to be positive. But if we take this as our number, when you multiply these two, negative 2 times 15, you're supposed to get negative 30, not positive 30. So this pair does not satisfy all the conditions. Look at the last pair. 3 times 10 is 30, but 3 plus 10 is also 13. So this is the pair that satisfies all the conditions, both conditions. Usually in case 1, once we find these two numbers, we already have our factors as x plus 3 and x plus 10, and we'll be just done at that point. But in the sum product method case 2, there are two extra steps that we have to follow. I like to call the third step, use the numbers that you found here, use the numbers to split the middle term and rewrite this first expression. So we have 2x squared. Instead of 13x, I'm going to use these two numbers here. So the 13x, I'm going to write it as 3x plus 10x. Because that is a positive 3, so positive 3x plus 10x. So instead of writing 13, I'm going to write 3x plus 10x plus 15. Okay, that's called the third step. We split the middle term. Now, we have to group this. The very last step says we have to group as 2 and factor each set and then factor again. So let's group them as the first 2 and the last 2. So we have to group and factor two terms in one group. Let's factor the first group separately and the next group separately. So to do the first one, if we look at it, we know that the GCF of these two terms is x. And we are left with 2x plus 3 in the parentheses. Now let's look at the next set, 10 and 15. We know 5 divides both of them. Positive 5 is the factor for both of them. So when we factor out the 5 times, the other factor left is 2x, and 5 times what goes into 15 is 3. So if you look at this point, you should notice that whatever comes in the parentheses is always the same. If they're not the same, we made some mistake somewhere. We have to go and check our work. So we just grouped them as 2 and we factored, but it says then factor again. One last time we have to factor it again. So in this case, we know that there's a plus sign right here. That is the one that divides them into two terms. So we have a term here and we have a term here. In both these terms, what do we have in common? When we factor, we know that whatever is in the parentheses is the common factor for both of them. So taking away 2x plus 3 from the first factor, we have left a factor of x. Taking away 2x plus 3 from the second one, we have a factor of positive 5 left. So that's how we factor. We are done. This is how we factor for case 2. Let's do one more example. So here step 1 is to write down what's our a, b, and c. So we have 6, -7, and -5. The second step, we have to find two numbers whose sum is b, and when you multiply, the product has to be a times c. So b is -7 and a times c is 6 times -5 is -30. So let's figure out two numbers which adds up to -7 and multiplies to -30. Let's start by factoring the 30. 30 can be written as 1 times 30, 2 times 15, and 3 times 10. So when we look at these three pairs, we will quickly see that the one that works is the last one, because that's the only way we can get -7 if 10 is negative and 3 is positive. So when you multiply, you get -30. When you add, you get -7. So we are going to rewrite this trinomial 6x squared. We're going to split the middle term. The -7x is going to be written as using these two numbers that we found. We're going to write it as positive 3x minus 10x. Positive 3x minus 10x will give us -7x itself. So I use instead of writing -10x, I'm going to use these two numbers to represent it. I make it in the trinomial into a polynomial with 4 terms. And we know the third step is to split the middle term, and that's what we just did. The fourth step, we have to group and factor, and then we have to factor again, right? That's what we discussed before. So let's group them as the first two and the last two, and we have to factor each group separately. In the first group, the GCF is 3x, so I'm left with 2x plus, if the 3x is completely gone, you just leave a 1. So just double check to see if this is correct. 3 times 2 is 6, x times x is x squared, 3x times 1 is 3x. It is perfect. The second one, if you look at it, they both have a negative. We can take -5 as our GCF. So when you take a -5, you're left with 2x. When the -5 is gone, so it's just a positive 1. So as we talked earlier, whatever comes in the parentheses have to be the same thing. That's how we know we're on the right track. And lastly, we have to factor again. So we are going to factor whatever is in the parentheses. We're going to factor that out and going to write it as 2x plus 1. And what's left is the 3x and the -5, which is our second factor. So that's how we factor trinomials. When a is not equal to 1, we have 2 extra steps and we get our expression factored.